Alright guys, today is our last day of factoring notes and tomorrow will be a quiz. So let's go ahead and get started here. 1 through 3 is factoring. You'll notice the directions change for the rest of them where they say solve by factoring. There's a difference and we'll talk about that. So factor. First look for a GCF. There isn't one. And this is a perfect square, but this is not, and for those rules that we talked about yesterday, they have to be what we call binomials, or two terms, and this one has three terms. So you're going to be thinking about the first day when we did something like this. So we want to think about combinations that multiply to 1, which are 1 and 1. Combinations that multiply to 15, or factors of 15, which are 1 and 15, 3 and 5. So what should we try, 1 and 15 or 3 and 5 if we're trying to get 8 negatives? We're probably going to try the 3 and the 5. That's going to get me 5x's and 3x's. Can that get me negative 8x's? Yeah, if the 5 is negative and the 3 is negative, so we put the negative here and here. And that works out to be positive 15 because last term, negative 3, times last term, negative 5 equals 15. So then my answer is going to be x minus 3, x minus 5. Those are my two factors. Number 2, there's no GCF. This is a perfect square, and this is a perfect square. There's a minus in the middle, so it fits this exactly. So let's think about what's being squared here is x, so that's my a value. What's being squared here is 9, that's my b value. What do I do with a and b? All right, x plus 9, x minus 9. And those are my two factors. All right, let's keep going to number 3. Here's our cube table in case we need it. This is a perfect cube, and 216 is a perfect cube right here. So this is following this pattern. What's being cubed here is x. What's being cubed here is 6. So this is my a value. 6 is my b value. And here's what you do with those a and b values. First of all, you keep the same sign. So it says plus, so we're going to add them. So it's going to be x plus 6. Then I do my a term squared. So x squared. Opposite sign. So it was plus, so now minus. Multiply a and b together. Multiply x and 6 together. Finally, add b squared. Add 6 squared, which is 36. And those are my two factors. So that's a good review of factoring. This was day 1, Tuesday. These are things we did Wednesday. And today is Thursday. Now, how does factor compare to the directions that say solve? Well, let's take a look. Notice I purposely did 1 and 2 the same. So here it was just x squared minus 8x plus 15. Here's the same thing, but I put up equals 0. So now we're actually finding x. That's what we mean when we say solve. Find x. And this here, you just leave your answer as your two factor since it says factor. So we already know that this is going to factor into x plus 3, x minus 5, because we did that up above. Once you have one side factored and the other side is 0, you do what's called zero product property. Because these are being multiplied and my answer is 0, either this could be 0 or this second factor could be 0. So we set each of those equal to 0. X plus 3 equals 0, x plus 5 equals 0. Then we just solve these just like regular, so add 3 to both sides. You get x is 3, add 5 to both sides, you get x is 5. And you can always check your answer. So if I plug this 3 in here for x here and here, I will get 0. If I plug in 5 for x here and here, I will get 0. That's how you can check your work. This was what we mean by solve. Take your factors, and then it's equal to 0, so then we can solve and find what x is. Number 5 is just like the beginning of number 2. So we know that the left side is going to factor into x plus 9x minus 9. Because we have multiplication and it's equal to 0, one of these two things being multiplied has to be 0. That's, again, the zero product property. So I'm going to set this factor equal to 0 and set this factor equal to 0. Go ahead and solve each separately. So subtract 9. And then over here, add 9. And those are my two answers. You could plug them both in. Now, I didn't copy number 3 down here because we're not going to do zero product property with something like this for today. So I kind of have a new one here. So let's look at number 6. Factor and then solve. So first, we have a 0 on one side. That's what we want. We want to factor this left side. So is this a perfect cube? Nope, not a perfect square. So we're just thinking something like this. So we're thinking, what multiplies to 3? Well, the only choices are 3 and 1. What multiplies to 10 is either 1 and 10 or 5 and 2. So think about which one you want to try and pause the video and try to factor that side. I'm going to try 5 and 2. That will give me 6x's. And this will give me 5x's. 6x's and 5x's gives me 11, so they're both going to be positive, so I get positive 11. And my third term still works. 5 times 5 gives me my last term of 10. So I've completely factored now. I have factors on the left. It's equal to 0. Now, just like I did over here in questions 4 and 5, I'm going to set this factor equal to 0, and I'm going to set this factor equal to 0. So 3x plus 5 equals 0, x plus 2 is 0. And then I'm going to solve these separately. So over here, this is going to be a quick one. You're just going to get x equals negative 2. Over here, subtract 5 on both sides, divide by 3. And so those are my two answers, negative 2 and negative 5/3. I would just leave your answer as a fraction. Okay, let's try some more. The directions here are still solve, and we're solving by factoring. You'll always want to get everything to one side and a 0 on the other side. So before we get too far in number 7, move the x over, subtract x on both sides, move the 20 over, subtract 20 on both sides. Now try to factor the left side. We don't have this pattern or this pattern. We don't have perfect squares or perfect cubes. So you're going to think about the first method from Tuesday, just combinations of 1 and combinations or factors of 20. 1 times 1 is 1x squared. For 20, we have 1 and 20, 2 and 10, or 4 and 5. I'll go with 4 and 5 since you want to get negative 1x. Which one would need to be negative, the 4 or the 5? The 5 needs to be negative. So I have negative 5x's and a positive 4x's. Once I have it factored and set equal to 0, I set each factor equal to 0. So I have x plus 4 equals 0. And x minus 5 equals 0. And those are pretty quick to solve. My answers are negative 4 and 5. Again, you can always check your work by plugging it in. So if I wanted to check 5, I would plug 5 in here. 5 squared is 25. And then I would have to plug 5 in here. 5 plus 20 is 25. And 25 equals 25. So I know this one is correct. And then I could check negative 4 also. Number 8. I have 0 on one side, which is what I want. So I need to factor the left side. There are two terms. Is it a perfect square, perfect cube? No, 5 is not a perfect square. So it won't follow this pattern. It's not a perfect cube. It won't follow this pattern. Is there a GCF? Yeah, they both have a 5 in common. They both have an x. So let's divide by or factor out 5x. Dividing by 5x, I get x. Divided by 5x, I get minus 2. If I were to redistribute that, that would be 5x squared minus 10x. Now notice we have two factors here, just like we did over here and in the other ones. So because I take 5x times x minus 2 and I get 0, I can set each piece equal to 0. 5x equals 0, x minus 2 equals 0. How do I solve something like this? Well, for this, if x is being multiplied by 5, I divide by 5. What's 0 divided by 5? 0. So my answers are 0 and 2. And you're going to have to show your work on your homework. You're going to have to show that you got a 0 on one side of the equation, that you factored the other, and then you finish solving by zero product property. Number 9, we have a 0 on one side. That's always where we want to start. We want to get all the terms to one side. And then we want to look for a GCF in either of these patterns. We have a GCF. They both have a 2. So go ahead and factor out that common 2. Now you'll notice what's left still says x squared, which is a perfect square. And 49 is a perfect square with a minus sign. So we're following this perfect square pattern here. What's being squared is x. What's being squared is 7. So here's what we do with what's being squared, our a and our b. X plus 7 and x minus 7. That 2 just tags along on the outside. Now let's set each piece equal to 0. 2 equals 0, x plus 7 equals 0, x minus 7 equals 0. Well, what is this going to do? What is 2 equals 0 going to do? That's not going to give me any solution, so don't write no solution, but this just isn't going to give me an x value that I need for an answer. But this will, if I subtract 7 on both sides, I will get answers of -7 and 7. There was no x here, so that's why I didn't get a solution from that factor. All right, good. We have 3 left. If you want to pause the video and attempt them without any help, that might be a good idea. Let's look at 10. First step, get 0 on one side. That's what we have. On the left side, we want to look for a GCF and factor. Notice that we have a negative coefficient. We don't like that, so let's factor out a negative. Divide both terms by a negative. Now you could divide both sides by a negative if you wanted to here. I'm just going to leave the negative out front because that's how we do it when we normally factor. What's left is x squared. That's a perfect square. 36 is a perfect square. There's a minus sign. So kind of like the last problem, we're following this pattern. X is being squared here. That's my a value. 36 is being squared here. That's my b value. So I can write this as x plus 6, x minus 6. Set each piece equal to 0. So again, this negative here is like a -1. I set these equal to 0. And then this is going to give me a value of x equals -6, a value of 6. And this one here, you don't have to do anything with that because that has no x's in it, so it doesn't give me any other values. Again, don't put no solution because of this. It just is not going to give you another x value for your answer. All right, we'll watch 11 and 12 in the next video.